Hi guys, welcome back. So today we are going to continue our lesson on transformation, and we are going to focus on a transformation which will be helpful for you if you will be an architect or an engineer someday, or if you like taking photos. Okay, so take a look at this example on the first slide. We have here a blueprint, okay, of a house. So if you will be an architect, you're going to use this lesson to make a blueprint. Also, you can see here, right, the map of the United States. Okay, of course, this one, the length of this map doesn't show the real area of the country USA. But this map was used based on a scale factor, which is an application of our lesson for today. So for today, we are going to focus on dilation. And just like before, you are going to finish watch this video, and as you do so, you're going to complete the guided notes on our dilation. Afterwards, we hope that at the end of this video, you will be confident to do our practice activities as our worksheet and our Alex activity on dilation. So let's take a look at our goal for today. So for today, we are going to perform and describe dilation on a coordinate plane. Also, we will learn how to get the scale factor of dilation. And finally, we will identify if images are similar by the use of dilation. So we are going to finish our guided notes, and hopefully we will be confident to answer the practices about dilation after. So let's dive in. So let us define a dilation. So once again, before we start, I am reminding you to complete your guided notes as you listen to the video. So a dilation is a transformation which is similar to a scale drawing. It uses a scale factor to enlarge or reduce a figure proportionally. Scale factor is a ratio of the side lengths of the image to the side lengths of the pre-image. And remember, for dilation, the pre-image and the image are the same shape, but not necessarily the same size. So as you can see, I have an example here of a dilation in these two triangles. Okay, we have triangle ABC, and it was dilated to form triangle A prime, B prime, and C prime. As you can see here, okay, the purple triangle is an enlarged version of our pre-image. Okay, and if you want to take a look at the scale factor, it's very easy to find. We will only get the ratio between the side lengths of our image. This is our image, and the side lengths of our pre-image. Okay, so ratio means just division. Okay, and also you have to remember this one. When you get the ratio, you have to get the ratio of the corresponding side. So for example, A prime, B prime over the ratio to the side AB. So as you can see, A prime B prime is 2 centimeter and our AB is 1 centimeter. So the ratio, the scale factor that we have used is 2. So this 2 scale factor is actually the same for every corresponding pairs of these two triangles. So for example, we have C prime, B prime, and then we take the ratio to side CB. C prime B prime is 4, while CB is 2. And as you all know, when we divide 4 and 2, it will become 2 as well. Okay, so this one is what we call dilation. We are enlarging or reducing an image based on a scale factor. So let's complete our definition of dilation in your paper. So just like before, remember you can pause the video for a while as you complete your notes. Okay, so remember we have different kinds of dilation actually based on the scale factor. So remember, if your scale factor is between 0 and 1, the dilated figure will be smaller than the original. Okay, if it's equal to 1, nothing will happen. It will be the same size as the original. If it's greater than 1, it will be larger than the original. So you can determine the scale factor for dilation that maps one figure onto another figure. So this is an example of dilation of rectangle ABC. As you can see for the first example, for our first example, our scale factor is less than 1. Okay, it's between 0 and 1. That's why our image, this rectangle A prime, B prime, C prime, D prime, is smaller than our original image, our pre-image. Okay, because the scale factor is between 0, and 1. And look at the second example. We have your scale factor of 1. It remains the same thing. So this one is our original image, our pre-image ABCD. It's since the scale factor is 1, nothing will happen. It will be the same size. Okay? And if the scale factor is greater than 1, as you can see here, our purple rectangle is bigger. Okay? It's an enlargement of our pre-image. So the size of our image will depend on the scale factor that we are going to use to dilate our figure. Okay, now how are we going to find the scale factor? So remember, the scale factor is only the ratio of the side lengths of the pre-image to the side lengths of our image. The scale factor is the ratio of the side lengths of our image to the side lengths of our pre-image. Okay, so remember that one. We are going to write first this is our pre-image and this is our image. Our triangle ABC was related to make triangle XYZ. Okay? So therefore, to get our scale factor, we get the ratio of our side lengths of our image, okay, the dilated image, to the side length of our pre-image, the original image. Okay? So you can actually take any corresponding sides. But if you want to make sure, you can actually do all three pairs of corresponding sides. So let's start by our first sides. So we have ZY. Okay, so we have side CY, we get the ratio to side CB. As you can see, our ZY is 4 and our CB is 2. And 4 divided by 2 is 2. Let us check that one to our another pair of corresponding side. We have YX and it corresponds to BA, this one. So as you can see, our YX is 4 and our BA is also 2. So the scale factor is 2. And finally, we have ZX. ZX corresponding to ZA. So you have 5.6 divided by 2.8 and it's actually equal to 2. So therefore, the scale factor here, so this scale factor is 2. Okay, for this dilated image. Since it's greater than 1, as you can see, we have an enlargement for this dilation. Okay, that is basically how do we get the scale factor. Okay, now let's move on to our square ABCD. What's related to make square EFGH? So remember, EFGH is our image and ABCD is our pre-image, our original shape. Okay, so we're going to find out the scale factor. So remember, we get the corresponding. So we have your EF correspond to AB. So we have 1 over 4. So the scale factor is 1/4. Okay, or 1 is to 4. Okay, or 25%. We also take, let's say, the next one, FG. Okay, FG, the corresponding side is BC. And that is actually 1/4. Okay, and as you can see, if you do the rest of it, we have HG correspond to DC. It's also 1/4. Okay, EH correspond to AD is also 1 over 4. So our scale factor for this dilation is 1 over 4. And as you can see, this one is a reduced image because our scale factor is less than 1. Okay, between 0 and 1. So basically, that is how we get the scale factor. It's very quick and easy, and I'm very sure you got it. You will get this one right. Okay, complete your notes for this example 1 and 2. Okay, moving on. Okay, to our third and fourth example, so that we are going to make sure that we know how to get the scale factor. So for this one, triangle DEF, so this is our pre-image, is related to make triangle GHI. This is our image. And obviously, as you can see, it's an enlargement. So we have to get a scale factor more than 1. Okay? Greater than 1. So let's try the first one, HI, corresponding to EF. I hope you get how to get the corresponding. So you have 10 over 5, and the answer is 2. So we get GI, side GI, correspond to side DF. So we have 6 divided by 3, and the answer is also 2. Finally, you have HG over ED. So you have 8 divided by 4, the answer is 2. And remember, in a dilated figure, the scale factor should also be the same, consistent, okay, for all corresponding sides. So here, our scale factor is 2. Okay, let's have our last example for the scale factor. So triangle PQR, this is our pre-image, is related to my triangle STU. And obviously, as you can see, this one is a reduction, reduced form, okay, for our dilation. So we should get a scale factor less than, okay, less than 1. Okay, so let's try to start with the first one. So this is our STU. Yeah, that is our image. Okay, so let's try ST. Okay, correspond to PQ. So you have 3 over 6. Since 3 cannot be divided by 6, we can just simplify this one as a fraction. And we know that we can divide 3 and 6 by 3. So therefore, the simplest form is 1 half. Let's try the next corresponding pair. UT correspond to RQ. So you have 5 over 10. And 5 over 10 is also 1 half. Finally, you have SU correspond to RP. So you have 5.8 over 11.6. And as you can see, that is also 1 half. Okay, so therefore, the scale factor for this question is 1 over 2, 1 half. So basically, that is the first thing that I would like you to know for this lesson, how to identify the scale factor for our dilated images. And by the way, before I move on, if you don't have the drawing and you only have the measurement of the side, you can actually use the names, the letters of the names to get your corresponding side. Just always get the 2, okay? It's like DE, okay? You can have sorry, DE or ED, right? And then GH or HG, it's the same thing. You can have EF, right? EF and HI. And you have DF finally, and then GI. So you just have to make 2 pairs of numbers if you have these 3 letters for yours, for the names of your figure. Okay, now since we already know how to make a scale factor, in relation to dilation, we have actually what we call similarity. When do we say two things are similar? Two figures are similar if one can be mapped onto the other using a scale factor not equal to 1. Okay? Because the dilation does not change the shape of a figure, the image and the pre-image are similar. Okay, just like this example here at the side. Okay, so here for the dilation, okay, for similarity, the dilation must not be equal to 1. So it can be an enlargement or it can be a reduction. Okay, because we will not change here, okay, the shape of the figure, but only the size. So they are still similar. Just like here, we have a parallelogram E prime, F prime, G prime, H prime is dilated is a dilated image of a parallelogram EFGH with a scale factor of 2. This is our pre-image and this is our image. As you can see, we have a scale factor of 2 of every side of our parallelogram, of our 2 parallelogram. That's why they are similar to one another. Okay? Because EF and then E prime F prime over EF will give you 4 over 2, and that's 2. Okay? E prime H prime and EH, it's 4 over 4.4 divided by 2.2. It's also 2. Okay? So this one shows similarity. Okay? The sides are proportional to one another with the use of our scale factor. So how do we show the two triangles are similar using a dilation? Okay. So for us to show that these two triangles are similar, we have to get a scale factor. Okay, and we have to show that every corresponding sides of these two triangles will be proportional to one another. Okay, so imagine we have this triangle ABC, our pre-image. Okay, and then we have here a triangle DEF, a result of our dilation. Let's try to find out what is our scale factor to show that they are similar. Okay, so we take the ratio of the side lengths of our image, let's say DF, correspond to AC. And as you can see, DF is 10, AC is 5. So 10 divided by 5 is 2. Okay, let's do the same thing for the other corresponding sides. EF correspond to BC. You have 8 divided by 4, and that is also equal to 2. And finally, DE and AB. Okay, we have 6 divided by 3, and that is equal to 2. As you can see, since our scale factors are all the same, which is 2, okay, we can say that these two triangles are similar because every corresponding sides are proportional to one another. Okay, so that is how we use dilation to show if two triangles are similar to each other. Okay, so therefore, the triangles are similar because triangle ABC can be mapped into triangle DEF by dilating with a scale factor of 2. So it's basically so easy to identify two triangles are similar. Okay, but I would like you to remember this one. Okay, we have such thing as a congruent figure and a similar figure. How are they alike and how are they different? Okay, so they are alike because they don't change the shape of our images. However, they are different because when we say congruent figures, all the corresponding sides are equal. Okay, look at this one: SR, ZY, both 4. RQ and YZ 7. Okay, these two are congruent. So we can say that rectangle SRQP is congruent, okay, to rectangle ZYXW. Okay, they are congruent to one another. This is the symbol for congruent, the equal sign with the mustache on top. Okay, they are congruent because they have the same side lengths. Every pair of corresponding sides are the same. While these two triangles are similar because they have the same shape but they do not have the same size. Okay, as you can see here, triangle ABC, okay, is our pre-image and is dilated to make triangle DEF, our image, with a scale factor of, that's correct, of 2 because 10 divided by 5 is 2, 6 divided by 3 is 2, 8 divided by 4 is 2. Okay, so therefore we don't say the triangle ABC is congruent to triangle DEF. We say the triangle ABC is similar, okay, to triangle DEF. Okay, as you can see, look at the similar symbol. It doesn't have the equal sign. It's like two mustache. Okay, so this one is congruent, this one is similar. Okay, do not be confused with the two. So actually, these two are also example of dilation, wherein for the congruent figures, right, it's a dilation wherein the scale factor is 1 because the image does not change the size. Okay, well, for the second one, it's a dilation with enlargement because our scale factor is 2, greater than 1. Okay, so since we know already how to identify scale factors and we pretty already know how to get the dilation, now we're going to dilate on a coordinate plane. Okay, so a dilation is a transformation that enlarges or reduces a figure by a scale factor relative to a center point, and that center point is we call the center of dilation. If you remember in rotation, we have the center of rotation. Now in dilation, we have a center of dilation as well. Okay, but since we are only in pre-algebra, we will focus on the center of dilation, wherein it's the origin. So this one. Okay, this one is what we call the center of dilation. As you can see, our pre-image is dilated based on that center of dilation as well. For the second example, our center is here, the origin. Okay, so we are going to practice how to dilate an image with a center of dilation in the origin. Okay, so basically we only have one rule that we're going to follow since we already know the scale factor. So with the center of dilation in the coordinate plane is the origin, each coordinate of the pre-image is multiplied by the scale factor k to find the coordinates of the image. Okay? We are just going to multiply the coordinates of our pre-image to our scale factor, whatever the scale factor is, to get the coordinates of our image. Okay? So in coordinate notation, please remember this one. This is the coordinate notation for dilation. Okay? So to dilate an image in a coordinate plane xy, it will be equal to kx and then ky. K is our scale factor. Okay? Just like this example. Okay? We have dilated our image with 2x and 2y. Here, our k is 2. Okay? As you can see, this is our AC and that is 2. Okay, for our pre-image. And our A prime C prime is 4. So if you will get the ratio of the side lengths of our image, 4 over 2, and the scale factor will give you 2. Okay? So basically, that is the coordinate notation for a dilation. Very easy. Okay, let me give you more example. So for this one, just like what a while ago, this one is an enlargement wherein our scale factor is k. That's why when we write the coordinate notation, it's xy into 2x and 2y. So as you can see, if this is AC and this is A prime C prime, right? Uh, it's hard to say because it's a diagonal one, right? Maybe we can take this vertical line. Okay, so it's easy for us to compare the side lengths. So it's 1, 2, 3, 4, 5, 6, and then you have 1, 2, and 3. So you have 6 over 3, the scale factor is 2. That is why for coordinate notation, for this dilation is 2x and 2y, because our k is equal to 2. No need to copy this one in your notes, just listen for a while. Okay, another example will be this one. Okay, as you can see, our coordinate notation is 1 of x and 1 of y because our k here is 1 half. So looking at this one, this is our image, it's 1 over our corresponding side in our pre-image, that is 2. So the scale factor is 1 half. Okay, so this one is a reduction. And then finally, we can have this one, okay? XY, because here our scale factor is 1. So K is equal to 1. No change at all. As you can see, AB also correspond to A prime B prime, okay? It means that this AB will have the same measure with side length A prime B prime. Okay, no change will occur in our image. Okay, now it's our turn to dilate a figure based on our scale factor. Okay, so remember we always try to write first our pre-image. So you have negative 2, 1, B is negative 4, 3, and then C is 3, 2. So this is our pre-image. Remember that one. Okay, so let's graph it first. Negative 2 and 1 is this. That is A. So we have negative 4 and 3. Negative 4 and 3 is this one. This is our B. And our C is 3, 2. 3 and 2 is this one, C. So this is our pre-image. So it says in the figure, we're going to dilate the figure with a scale factor of 2. So when you have a 2 as a scale factor, remember, our coordinate notation will follow as 2x and 2y. It means we are going to multiply every coordinate in our pre-image by 2. Okay, so let's start with A prime. Okay, so we have negative 2 times 2. That will become negative 4. 2y, 2 times 1 is 2. So A prime will be negative 4 and 2. So negative 4 and 2 is this one. This is A prime. B prime, we will have 2x again. So 2 times negative 4 is negative 8. 2y, 2 times 3 is 6. So we have negative 8 and 6. This is negative 8 and 6. And then finally, our C prime is 3 and 2. So 2 times 3 is 6. 2 times 2 is 4. So we have 6 and 4. 6 and 4. This is our C prime. This is our B prime. So connecting these 3 points, we will have our dilated image. And as you can see, this one is an enlargement, okay, because our scale factor is 2, more than 1. Okay, so that's it. That's how we dilate an image. It's very quick and easy. Okay, let's take example number 2. Don't forget to fill in your coordinates and also your drawing, your figure, your pre-image and your image. Okay, let's move on to example number 2. So example number 2, we have another triangle, DEF. So triangle D has a vertex D has coordinate -2, -1. F is 0 and 1. E is 0 and 1, and F is 1 and -3. So our pre-image is this one. Pre-image. So let's draw it. -2, -1 is this one. That's D. 0 and 1. This is our E. And then our F is 1 and -3. This is our pre-image. Okay, it says here we have a scale factor of 3. So just like a while ago, let's write our coordinate notation. So we have a scale factor of 3, so it means 3x and 3y. So we're going to multiply every coordinates by 3. So 3 times -2 is -6. 3 times -1 is -3. So our d prime is -6 and -3. This is our d prime. E prime, 3x, 3 times 0, 0. 3y, 3 times 1 is 3. So 0, 3 is the next E prime. And F prime will just be 3 times 1 is 3. 3 times -3 is -9. 3 and -9. Oh, we don't have a -9. So let's imagine this is -9. Okay, so that is F prime. So as you can see, it's an enlargement with a scale factor of 3. So we connect that one. Okay. So if you have a ruler, it will be better if you will have a ruler for this one. Okay, so that will be our dilated image. Triangle D prime, E prime, and F prime with a scale factor of 3. Okay, we have last two examples. Okay, since we already have enlargement, let me show you how to do reduction. Okay, example number 3. So here we have triangle JKL and it has vertices 4, 8, 8, 6, and 8, 2. So let's list down. So J is 4, 8, K it's 8, 6, and then L is 8, 2. This is our pre-image. So J 4, 8, 4 and 8. This is J. 8 and 6, 8 and 6. This is our K. And 8 and 2. Okay, 8 and 2, this one, okay, is our L. And that is our triangle. Okay, JKL. And we're going to dilate this one with a scale factor of 1/2. Okay, so again, since our scale factor is 1/2, our coordinate notation will just be 1/2 x and then 1/2 y. It means we're going to multiply, every coordinate by 1/2. Remember, when you multiply every coordinate by 1/2, it means you're also dividing every coordinate by 2, because multiplying by 1/2 also means division by 2. So 1/2 times 4 means 4 divided by 2, and that is 2. 1/2 times 8 is 8 divided by 2, and that is 4. So J prime is 2, 4. So this is J prime. K prime, 1/2 times 8, so 8 divided by 2, it's 4. 1/2 times 6, 6 divided by 2 is 3. So we have 4 and 3 for our K prime. Then finally, for L prime, 8, 2. So 1/2 times 8, so 8 divided by 2, 4. 1/2 times 2, 2 divided by 2 is 1. So 4, 1 is our L prime. Then we just connect them. And this is our dilated image with a scale factor of 1/2. As you can see, our image is smaller than our pre-image. Okay. And lastly, for our last example, what if our scale factor is 2/3? Okay. Don't worry, we got this one as well. Okay, so just like what we're doing, we're going to list on our pre-image first. So we have E, -6, -6, F, 3 and 6, and then G, -3 and 3. So let's graph it. -6 and -6 is here. 3 and 6. So 3 and 6 is here. Okay, and then -3 and 3. -3 and 3 is here. Oh, this quite. So this is our E, F, and G. Okay, so our triangle is quite too far from each other. Okay. Okay, so that's our triangle EFG. Now we're going to dilate it with a scale factor of 2 over 3. Okay, so let's write first our coordinate notation. So xy is 2. So we're going to multiply every coordinates by 2/3. Okay, 2 over 3x and 2 over 3y. Okay, so don't worry, when you multiply by 2 over 3, it's quite easy actually. You can even use your calculator. Okay, so when you say 2 over 3 multiplied by -6, you can actually choose two ways. You can actually multiply -6 with 2, that will be -12, and then divide by 3 afterwards. So -12 divided by 3, that is a -4. Or if you want to make your numbers smaller, you can actually divide first before you multiply. -6 divided by 3 is -2, times 2 is -4. So it's up to you which one is ever easier for you. So -6 times over 3, so the same, -4. So our E prime is -4, -4. So this is E prime. For F prime, we have 2 over 3 times 3. Okay, so we have 2 times 3 is 6, divided by 3 is 2. Now we have 2 over 3y, so 2 over 3 times 6. 2 times 6 is 12, divided by 3 is 4. So we have 2 and 4. 2 and 4 is this one. This is our, okay, F prime. And then lastly, for our G prime, we have, okay, -3 and 3. So we have 2 over 3 times -3. 2 times -3 is -6, divided by 3 is -2. And then you have 2 over 3y, 2 over 3 times 3. 2 times 3 is 6, divided by 3 is 2. So we have -2 and 2. This is our G prime. So connecting all these 3 points. Okay, so this one is our dilated image with a scale factor of 2 over 3. Okay, so again, remember to dilate a figure in a coordinate plane, we just multiply every, okay, coordinate, every x and y in our pre-image, in our original image with, okay, the corresponding scale factor. Okay, so remember, if the scale factor is between 0 and 1, it will become a smaller figure. If it's equal to 1, it will be the same. If it's greater than 1, it will be an enlargement. Okay, that will also give you an idea if what you're drawing is correct or not. Okay, so there you have it. That is the lesson for the day, dilation. So what do we do now? Of course, I hope you have completed our guided notes. If you still have any question, please feel free to come to me and ask me a question to clarify things, or you can always go back to the part of the video wherein you are still confused. Okay, so for now, you have two options just like before. You can answer our dilation worksheet, or you can also answer our dilation activity on Alex. Okay, so don't worry, you got it just like the last one. Okay, thank you, and I'll see you again next time.